Callisto is the quiet moon of Jupiter. It has no volcanoes like Io, no bright cracked surface like Europa, and no giant magnetic mystery like Ganymede. From far away, it looks dark, frozen, and forgotten. But this ancient moon may be one of the safest places for humans to survive in the outer solar system. Its surface is covered with craters older than complex life on Earth. Beneath that frozen ground, there is water ice. Around it, Jupiter dominates the sky. And unlike Europa or Io, Callisto sits far enough from Jupiter to avoid the worst of its deadly radiation belts. That single advantage changes everything. Callisto is still brutal. It is freezing cold, airless, dark, and incredibly far from Earth. But with underground habitats, nuclear power, ice mining, and enough shielding, humans might one day build a real outpost there. Tonight, we ask one question. Could humans actually survive on Callisto? Before we begin, if you enjoy calm, cinematic space documentaries made for sleep, mystery, and deep cosmic questions, make sure to subscribe to Theories Before Sleep. Now get comfortable, because the quietest moon of Jupiter may become humanity's first home in the outer solar system. Callisto is the kind of world that does not ask for attention. It does not shine with bright colors. It does not erupt with volcanoes. It does not show giant cracks across its surface like Europa. It does not dominate Jupiter's system the way Ganymede does. From far away, Callisto looks quiet, dark, frozen, old, a moon covered in scars. But the longer we look at it, the more powerful that silence becomes. Because Callisto may be one of the most important moons in the entire outer solar system. Not because it is active, but because it is stable. Not because it is dramatic, but because it may be survivable. Callisto is Jupiter's second largest moon after Ganymede, and it is the outermost of the 4 great Galilean moons. Those 4 moons, Io, Europa, Ganymede, and Callisto, are some of the most fascinating worlds orbiting any planet. Io is volcanic and violent. Europa is icy and mysterious. Ganymede is enormous and magnetic. And Callisto is ancient. It orbits farthest from Jupiter among the 4 at a distance of about 1.88 million kilometers from the giant planet. That distance may sound like just another number, but for survival, it changes everything. Jupiter is not only a planet, it is a radiation machine. Its magnetic field traps charged particles and creates deadly belts of radiation around the planet. Any human trying to survive close to Jupiter would face an invisible storm of energetic particles that could damage electronics, harm living tissue, and make long-term settlement almost impossible without extreme shielding. This is why Io and Europa are so dangerous. They are closer to Jupiter. They live deeper inside that radiation environment. Callisto is different. It sits farther away, still inside Jupiter's kingdom, but not inside the worst of the danger. And that distance is Callisto's greatest advantage. It is the reason scientists have seriously considered it as one of the better places for a future human outpost in the Jovian system. Not because Callisto is warm. It is not. Not because it has air. It does not. Not because it is easy. Nothing around Jupiter is easy. But compared with the other major moons, Callisto is quieter, safer, and more forgiving. And in the outer solar system, more forgiving, can be the difference between impossible and possible. Callisto is slightly smaller than Mercury. Its diameter is about 4,821 kilometers, while Mercury's is about 4,880 kilometers. If you looked only at size, the two worlds are almost twins, but their compositions are completely different. Mercury is a dense, rocky planet with a huge metallic core, baked by the nearby Sun. Callisto is a frozen moon made of roughly equal parts rock and ice, orbiting in the cold darkness around Jupiter. One is a scorched inner planet. The other is an ancient icy world. Callisto's lower density tells us that it is not just rock. A huge amount of its body is water ice mixed with rocky material. Beneath the surface, there may even be layers of ice and perhaps a deep, salty ocean hidden far below, though this is still a subject of study. That possibility matters because water is survival. Water is not only something humans drink. It is oxygen. It is fuel. It is radiation shielding. It is farming. It is chemistry. It is the foundation of any long-term outpost beyond Earth. A frozen moon rich in ice is not automatically habitable, but it gives future humans something to work with. And Callisto has something else that makes it special. Its surface is one of the oldest and most heavily cratered in the entire solar system. In fact, Callisto is often described as the most cratered object we know. Its face is covered with impact scars, large craters, small craters, overlapping craters, ancient basins, bright rings, dark plains, and circular wounds left by billions of years of collisions. It looks as if space has been throwing rocks at Callisto since the beginning of time, and Callisto has simply taken the hits. On Earth, craters vanish, rain erodes them, wind softens them, oceans cover them, plate tectonics recycle the crust, life grows over the scars. Earth is always changing, always renewing itself. But Callisto barely changes at all. Its surface has remained largely frozen in time for around 4 billion years. That means when we look at Callisto, we are not just looking at a moon. We are looking at a record, a memory of the early solar system, a world that still carries the marks of ancient impacts from the age when planets and moons were still being shaped. Callisto is like an old book left open in space. Every crater is a sentence. Every basin is a chapter. Every scar tells us that something struck this moon long before humans existed, long before civilization, long before Earth had complex life, perhaps before our planet had even settled into the world we know today. And yet, Callisto survived. That may be the most haunting thing about it. It absorbed billions of years of impacts. It was struck again and again. It was battered by debris from the young solar system. And still, it remains almost perfectly intact, not melted into a volcanic world, not resurfaced into smooth plains, not torn apart by Jupiter's gravity, just ancient, scarred, still. Callisto was discovered by Galileo Galilei in January 1610 when he turned his telescope toward Jupiter and saw something that changed humanity forever: tiny points of light near Jupiter. At first, they seemed like stars, but night after night, Galileo watched them move. They were not fixed background stars. They were orbiting Jupiter. This was one of the most important moments in scientific history, because for thousands of years, many people believed that everything in the heavens moved around Earth, Earth was seen as the center. The moon moved around Earth. The sun appeared to move around Earth. The stars seemed fixed around Earth. But then Galileo saw moons orbiting another planet, not Earth, Jupiter. And suddenly, the universe became larger in a new way. Earth was not the only center of motion. Other worlds had companions. Other planets had systems. The sky was not built only around us. Io, Europa, Ganymede, and Callisto became evidence that the universe was far more complex than old models allowed. Callisto, quiet and distant, was part of that revolution. One of the first worlds beyond the moon that humanity recognized as a moon, a small point of light that helped change our place in the cosmos. For centuries after that, Callisto remained mostly a distant dot. Telescopes improved, but the moon was still too far and too small to reveal much detail from Earth. We knew it was there. We knew its orbit. We knew it was large, but we did not truly see it until spacecraft arrived. The Voyager missions gave humanity its first close looks at Callisto, and what they revealed was astonishing. A surface absolutely covered in craters, a world that looked battered beyond belief. No smooth young plains like those on Europa, no volcanic chaos like Io, no obvious recent activity, just an ancient frozen crust marked by impacts from almost every era of solar system history. Later, the Galileo spacecraft studied the Jovian system in greater detail. It helped reveal more about Callisto's composition, its surface, its possible internal structure, and its interaction with Jupiter's magnetic environment. The picture became clearer. Callisto was not just a dead ball of ice and rock. It was a preserved world, a moon that had avoided the extreme tidal heating that reshaped Io and Europa. Io is stretched and squeezed by Jupiter's gravity and by orbital interactions with the other moons, creating enormous internal heat and endless volcanic eruptions. Europa is also affected by tidal forces, likely helping maintain a subsurface ocean beneath its ice. Ganymede has its own magnetic field and a complex internal structure, but Callisto, farther out, experiences much weaker tidal heating. It has not been kneaded and reshaped as violently. It has remained quieter, older, more stable. For life as we know it, Europa may be more exciting because of its ocean, but for human survival, Callisto may be more practical. A human base on Europa would face intense radiation from Jupiter. The surface radiation environment would be extremely dangerous. Habitats would need massive shielding, and surface operations would be limited. Callisto, being farther from Jupiter, avoids much of that. This does not mean it is safe like Earth. It is still airless, still cold, still far from the sun, still exposed to cosmic radiation, still hostile. But compared with Europa, it is far less deadly. That is why Callisto has appeared in serious human exploration concepts. It has been considered as a possible base for studying Jupiter's system, operating robotic missions, accessing icy materials, and perhaps supporting long-term human presence. Imagine it, a human outpost on Callisto, far from Earth, standing under the enormous presence of Jupiter. Not on the closest moons, where radiation is severe. Not on Io, where volcanoes reshape the world. Not on Europa, where the surface is scientifically precious and radiation is dangerous. But on Callisto, the quiet outer moon, a base buried beneath ice and regolith, robots crossing cratered plains, antennas aimed back toward Earth, nuclear reactors or advanced power systems glowing below the surface. Astronauts living inside shielded habitats, looking out through cameras at Jupiter hanging in the sky. The idea feels almost impossible, but not completely. That is what makes Callisto so powerful. It is not friendly, but it may be realistic. Its surface gravity is low, only about 1/8 of Earth's gravity. A human walking there would feel much lighter. Every step would need care. Dust and ice particles would behave differently. Construction would be easier in some ways, harder in others. Heavy materials would weigh less, but anchoring structures would be important. Machinery would need to handle cold, vacuum, and low gravity. The temperature would be brutal. Callisto is far from the sun, and sunlight there is weak compared with Earth. Solar power would be difficult, though not impossible with very large arrays. A colony would likely need nuclear power or another reliable energy source. There is no breathable atmosphere, only an extremely thin exosphere, no pressure, no open water, no protection from vacuum. A person outside without a suit would die quickly. But again, human survival in space is never about walking outside unprotected. It is about building controlled environments. A Callisto colony would be underground or heavily shielded. The ice-rich surface could be mined for water. The rock could provide minerals. Regolith and ice could become shielding. Habitats could be placed beneath the surface to protect against radiation and micrometeorites. Food could be grown indoors. Oxygen could be generated from water. Fuel could perhaps be produced from hydrogen and oxygen. The moon itself could provide some of the raw materials needed to survive. Callisto's distance from Jupiter also makes it a good staging ground. From there, humans or robots could study the entire Jovian system. Missions could be sent inward to Europa, Ganymede, or Io. Callisto could serve as a safer base, a place to launch and control robotic explorers without placing human bodies directly inside the worst radiation zones. In that future, Callisto would not be important because it is the most exciting moon. It would be important because it is the safest door into Jupiter's empire, a quiet harbor at the edge of danger. But the landscape would be haunting. Imagine standing on Callisto's surface in a pressurized suit. The ground beneath you is dark ice and ancient rock. The horizon curves gently under a black sky. There is no wind, no sound except what travels through your suit. The craters around you are older than almost anything humanity has ever touched. Some may have formed when Earth itself was young. Above you, Jupiter hangs in the sky, huge compared with any planet seen from Earth. A banded giant of storms, clouds, and color. It does not fill the sky completely, but it dominates emotionally. It is not just a bright point. It is a world, a giant, a reminder that you are standing on a moon in the court of the largest planet in the solar system. And somewhere beyond that, Earth is just a distant point, so far away that messages take time to cross the gap. Depending on the positions of Earth and Jupiter, a radio signal may take around half an hour or more to travel one way. A conversation with home would not be immediate. You would send a message, wait, receive a reply later. Every call would feel like speaking across distance and time. This isolation would be part of survival too. Callisto is not only physically cold, It is emotionally distant. A human outpost there would be one of the loneliest places ever created. The people living there would be surrounded by science, machinery, ice, and darkness. They would rely on each other completely. They would depend on systems that cannot fail. They would be far beyond quick rescue from Earth. But they would also be part of something extraordinary. The first human foothold in the outer solar system. The first step into the realm of Jupiter, a base on one of the oldest surfaces we know. A place where humanity could study the scars of creation while learning how to survive far from the sun. That is why tonight's question matters. Of all Jupiter's moons, could Callisto be the one we call home? Io is too violent. Europa is too irradiated and scientifically delicate. Ganymede is fascinating, but still deeper in Jupiter's environment than Callisto. Callisto is not gentle, but it is distant enough to offer a chance. A frozen, cratered, ancient world that may contain water, shielding, and relative safety. It may not be the most beautiful moon. It may not be the most active. It may not be the one that hides the most obvious ocean mystery, but it may be the one where humans could stay. That possibility changes how we see it. The scars stop looking only like damage. They become history. The ice stops looking only like frozen emptiness. It becomes a resource. The distance from Jupiter stops making Callisto feel remote. It becomes protection. The silence stops feeling useless. It becomes stability. Callisto is a world that survived by being far enough away. Far enough from Jupiter's worst radiation. Far enough from the strongest tidal violence. Far enough to remain ancient. Far enough to become, perhaps, the safest of the Galilean moons. And there is something beautiful about that. In the solar system, danger often comes from closeness. Too close to the sun, and Mercury burns. Too close to Jupiter, and Io is torn open. Too deep in radiation belts, and Europa becomes dangerous. But Callisto waits at the edge, not free from danger, but spared from the worst. A moon of distance, a moon of scars, a moon that remembers the early solar system because nothing fully erased its memory. And maybe, one day, if humans become patient enough, careful enough, and brave enough, lights will appear beneath its frozen surface. Not cities under open skies, not oceans and forests, but habitats, tunnels, research stations, warm rooms below ancient ice, human voices carried through pressurized corridors, plants growing under lamps, water mined from frozen ground, Jupiter watched through shielded cameras, a small island of life on a moon that has been silent for 4 billion years. Callisto has waited a long time. It has watched impacts come and go. It has orbited Jupiter through the entire history of life on Earth. It was already old before humans existed. It will still be there long after our time. And perhaps that is what makes it feel so strange. A world so ancient, so scarred, so distant, may still become part of our future. Tonight, we begin with that possibility. Not that Callisto is easy, not that it is safe, not that it is waiting for us kindly, but that among the moons of Jupiter, this quiet, battered world may offer something rare, a chance, a place where humans could hide from radiation, mine ice, build shelter, study the giant planet, and survive at the edge of the outer solar system. Of all Jupiter's moons, Callisto may be the one that lets us stay. Jupiter is beautiful from a distance, a giant planet wrapped in bands of white, orange, brown, and gold, a world of storms, clouds, lightning, and impossible scale. the largest planet in the solar system, a place so massive that, in many ways, it is almost a failed star. But Jupiter is not only beautiful, it is dangerous. Not just because of its gravity, not just because of its storms, not just because of its size. Jupiter is surrounded by one of the most hostile radiation environments in the solar system. Invisible belts of charged particles are trapped by its enormous magnetic field. Electrons and ions circle the planet at high energy, creating a region of space that is deeply hazardous to electronics, spacecraft, and living tissue. Around Earth, our magnetic field protects us. Around Jupiter, the magnetic field becomes part of the danger. It is huge, powerful, and violent. It captures particles, accelerates them, and holds them in radiation belts that extend far out into space. Any spacecraft entering this region must be heavily protected. Any human body exposed there would be in extreme danger. This is one of the greatest problems with exploring Jupiter's moons. The moons are not simply floating peacefully around a giant planet. They are moving through an invisible storm. Io, the innermost of the 4 Galilean moons, sits deep inside this radiation environment. It is already a nightmare world for other reasons, covered in volcanoes, sulfur, lava flows, and tidal violence. But the radiation around it makes human survival almost unthinkable. Europa is more tempting. It has a global ocean beneath its ice. It may be one of the best places in the solar system to search for alien life. Its cracked white surface is beautiful and mysterious. But Europa orbits deep inside Jupiter's radiation belts. Its surface is constantly bombarded by energetic particles. For unprotected humans, Europa's surface would be deadly very quickly. A base there would need extreme shielding. Astronauts could not simply walk around freely in suits for long periods. Surface operations would be limited. Electronics would need protection. Habitats would have to be buried under thick ice, deep enough to reduce the radiation to survivable levels. Europa may be one of the most scientifically exciting worlds we know, but it is not the easiest place for people to live. Then there is Ganymede. Ganymede is the largest moon in the solar system, even larger than Mercury. It is extraordinary because it has its own magnetic field, the only moon known to have one. That gives it some protection and makes it deeply fascinating. But Ganymede still orbits inside Jupiter's radiation environment. Its magnetic field helps, but it does not make the surface Earth-like. The radiation problem remains serious. It is better than Europa in some ways, but still difficult. And then, farther out, there is Callisto. Quiet Callisto. Dark Callisto. The moon that often gets ignored. Callisto orbits farthest from Jupiter among the 4 Galilean moons. And that distance changes everything, because Callisto sits outside Jupiter's main radiation belts. This is Callisto's greatest survival advantage. Not its beauty, not its size, not even its ice, its distance. Callisto is far enough from Jupiter to avoid the worst of the radiation storm. It still experiences radiation. It is still not Earth. It is still an airless moon in deep space, exposed to cosmic rays and solar particles. But compared with Io, Europa, and Ganymede, the difference is enormous. This single fact transforms Callisto from just another icy moon into one of the most practical places for human survival in the outer solar system. On Europa, radiation is a central enemy. On Callisto, radiation becomes a manageable engineering problem. That is the difference between a place where humans must hide desperately and a place where humans might realistically build. The surface radiation on Callisto is still higher than what we experience on Earth. A person would still need a spacesuit. A habitat would still need shielding. Long-term exposure still has to be controlled. But the levels are low enough that basic shielding strategies become effective. Ice, regolith, water, habitat walls, buried structures. These are not exotic technologies. They are difficult to build far from Earth, yes, but the principle is simple. Put material between humans and radiation. The more material, the safer the people inside. And Callisto has the material. Its surface is rich in ice and rock. The very ground beneath a future colony could become its shield. Instead of importing every protective layer from Earth, a Callisto base could use the moon itself, dig into the surface, pile ice and regolith over habitat modules, build tunnels beneath the crust, place water tanks around living areas, use local material as armor. The moon that looks cold and dead suddenly becomes protective. Its frozen surface becomes a wall between life and Jupiter's radiation. This is why Callisto is so different from Europa. On Europa, the ice can shield a base too, but the radiation above is so severe that the required protection, planning, and operational limits become much more demanding. Surface missions are dangerous, equipment suffers, human activity must be carefully restricted. On Callisto, humans could still not walk outside casually, but the radiation environment would allow far more flexibility. Rovers could operate longer. Astronauts could perform surface work with less extreme exposure limits. Habitats would still need cover, but not the same desperate depth required on the more irradiated moons. Emergency scenarios would be less catastrophic. A failure in shielding would still be dangerous, but it would not be the same as being exposed deep inside Jupiter's harshest radiation belts. That is the difference between a harsh world and an impossible one. Callisto is harsh. Europa is far more punishing. And Io, for humans, is almost a nightmare. When people imagine living near Jupiter, they often focus on the view. Jupiter huge in the sky, the bands, the storms, the great red spot, the beauty of standing on a moon beside the largest planet in the solar system. But the true question is not what the view looks like. The true question is how long you can survive under it. A beautiful sky does not matter if the radiation kills you. Callisto gives humans a chance to see Jupiter without living inside the worst of its invisible violence. From Callisto's surface, Jupiter would still be enormous compared with how it appears from Earth. It would hang in the black sky as a giant disk, banded and bright, a reminder that you are far from home and deep in the outer solar system. But unlike Europa, the sky would not be as deadly. That matters more than poetry. It matters for architecture. A Callisto habitat could be simpler than a Europa habitat. Still complex, still expensive, still a miracle of engineering, but simpler in one crucial way. It would not need to fight the same level of radiation every second. A base might be built partly underground, with surface entrances covered by mounds of ice-rich regolith. The living areas would be below the surface, protected by meters of local material. Radiation storm shelters would exist, but the whole colony would not feel like it is constantly under siege in the same way a Europa base might. The walls could be thick, the ceilings covered. The windows, if there are any, would be rare and heavily shielded. Most views of the outside would come through cameras, screens, and protected observation systems. But that is normal for deep space survival. The real victory is that the colony could function without extreme radiation dominating every single decision. On Callisto, cold is the bigger enemy. Distance is the bigger enemy. Power is the bigger enemy. Isolation is the bigger enemy. Radiation is still present, but it is not the monster it becomes closer to Jupiter. This changes mission design. If humans wanted to explore the Jovian system, Callisto could become a base camp, not the final destination for every scientific question, but the safest place to put people. From there, robotic spacecraft could be sent inward to Europa, Ganymede, and Io. Humans could control them with much shorter delays than from Earth. Supplies could be stored. Fuel could be produced. Equipment could be repaired. Science operations could be coordinated from a safer moon. Callisto becomes the harbor. Jupiter's system becomes the ocean. Europa is the dangerous treasure island. Io is the volcanic hell. Ganymede is the giant mystery. And Callisto is the place where humans can breathe inside a habitat and survive long enough to study them all. That is why serious human exploration ideas for Jupiter often begin with Callisto. Not because it is the most exciting moon, because it is the most survivable one. In space, survivability often wins. A place can be scientifically fascinating and still be a terrible location for a human base. Europa may hide life beneath its ice, but that does not automatically make it the best place for astronauts to live. In fact, if Europa may have life, that creates another problem: contamination. Humans landing there would have to be extremely careful not to pollute a potentially living world. Callisto avoids some of that concern. It may have a subsurface ocean too, but it appears less geologically active, less likely to exchange surface material with a deep ocean in the same way Europa might. That does not mean we can be careless, but it makes Callisto feel more practical as an outpost location. A human base does not need to sit directly on the most delicate science target. It can sit nearby, somewhere safer, and send robots where humans should not go. Callisto's radiation advantage also reduces energy costs. That may sound strange, but shielding is not just about walls. It is about mass, construction, maintenance, replacement, and operational limits. A colony in a high radiation zone needs stronger protection, more buried infrastructure, more hardened electronics, more emergency procedures, and more limits on surface activity. All of that costs energy. Energy to dig, energy to move material, energy to manufacture shielding, energy to repair damaged systems, energy to protect electronics, energy to keep people safe during radiation events. On Callisto, the lower radiation environment reduces those burdens. A base still needs power, but it can spend less of its total effort fighting Jupiter's radiation and more effort solving other problems. And Callisto has many other problems. It is far from the sun, so sunlight is weak. Solar power would be much less efficient than on Earth or Mars. The colony would probably need nuclear reactors or advanced energy systems. The cold would be extreme. Machinery would need heating. Lubricants, seals, batteries, and electronics would all have to be designed for deep cold. The surface is ancient and rugged. The gravity is low. The distance from Earth creates communication delays. Resupply would be difficult. Medical emergencies would be terrifying. Psychological isolation would be intense. But none of these problems matter if radiation makes the place instantly unlivable. Callisto clears that first Great Barrier. It says, you can stay here long enough to solve the rest. That is why its distance from Jupiter is not a weakness. It is humanity's greatest asset in the Jovian system. Closer is not always better. Closer to Jupiter means a bigger view. Closer to Jupiter means stronger tidal forces. Closer to Jupiter means more radiation. Closer to Jupiter means more danger. Callisto survives because it is distant. Its quiet orbit is its shield. Its loneliness is its protection. From a storytelling point of view, Callisto may seem less dramatic than Io or Europa. It does not constantly erupt. It does not promise an ocean just beneath the ice. It does not have the same famous mystery. But for a human being trying to stay alive, boring can be beautiful. Stable can be beautiful. Far away can be beautiful. The safest place is not always the most spectacular one. It is the one where the invisible threats are low enough for engineering to matter. Callisto gives engineering a chance. Imagine 2 future mission plans. One places humans on Europa. The science is incredible, but every surface hour is expensive, risky, and radiation limited. Habitats must be deeply buried. Rovers must be hardened. Astronauts must remain protected. Every emergency becomes more dangerous because exposure outside is so punishing. The other place is humans on Callisto. The science is still valuable, the ice is abundant, and Jupiter's system is accessible. Radiation still matters, but it does not dominate the mission in the same way. Surface operations become more practical. Habitats still need shielding, but not an absurd battle against Jupiter's strongest belts. For long-term survival, Callisto wins, convincingly. That does not mean Callisto is easy. Nothing in the outer solar system is easy. But among the Galilean moons, Callisto is the one that gives humans the greatest margin for error. A margin for error is everything. A colony cannot survive if every mistake is fatal. It needs time to repair, time to adapt, time to learn, time to recover from failures. Callisto's lower radiation environment gives humans more time, more flexibility, more options. A future Callisto colony might start small, a robotic landing zone, then power systems, then buried storage, then autonomous digging machines, then habitat modules lowered into trenches and covered with ice regolith shielding, then life support systems, then humans. The first crew would arrive not to an open city, but to a protected outpost already prepared by machines. They would live underground, but they would not be buried in fear. They would know that above them, the surface is dangerous, but not impossible. They could send rovers across the cratered plains. They could study ancient impact basins. They could drill into ice. They could build landing pads. They could assemble spacecraft. They could control missions deeper into Jupiter's system. They could look up at Jupiter and know they were close enough to study it, but far enough to survive it. That is the balance Callisto offers. Close enough to matter, far enough to live. Radiation is invisible, and because of that, it is easy to underestimate. A crater looks dangerous. A cliff looks dangerous. A volcano looks dangerous. But radiation is silent. You cannot see it. You cannot hear it. You cannot smell it. By the time the body feels the damage, it may already be too late. This is why Callisto's advantage is so important, even if it does not look dramatic. It is the difference between a place that quietly protects you and a place that quietly kills you. On Europa, Jupiter's radiation is a constant warning. On Callisto, Jupiter is still dangerous, but more distant. The giant planet becomes something humans can study from a safer shore. And maybe that is Callisto's role in our future. Not the moon of fire, not the moon of hidden life, not the largest moon, but the moon that lets us stay, the place where humans can build the first real foothold in Jupiter's realm, a shelter at the edge of the radiation storm, a base under ancient ice, a quiet outpost on the most scarred surface in the solar system, a place where distance becomes protection. And there is something deeply human in that. We often dream of the most dramatic destinations, the highest mountain, the deepest ocean, the most mysterious moon, the brightest world. But survival often begins somewhere quieter, somewhere less glamorous, somewhere just safe enough. Callisto may be that place. The quiet moon nobody talks about. The moon that does not shout for attention. The moon that does not glow with volcanic fire or crack with ocean mystery. The moon that simply waits, far from Jupiter's worst fury, carrying ice, rock, darkness, and 4 billion years of scars. And if humans ever enter the outer solar system to stay, it may not be Europa that saves us first. It may be Callisto. Because in the kingdom of Jupiter, where radiation rules like an invisible storm, Callisto's distance is not loneliness, it is mercy. Standing on Callisto would feel like standing on the memory of the solar system. The first thing you would notice is not movement, it is stillness. No wind, no rain, no clouds, no blue sky, no sound traveling through air, just a black sky above you, Jupiter hanging far away but enormous, and beneath your boots, one of the oldest surfaces humanity has ever imagined touching. Callisto's surface is not smooth, it is not young, it is not clean or bright like Europa. It is a frozen, battered landscape, covered with craters in every direction, small craters inside larger craters, old basins half buried by newer impacts, bright icy scars surrounded by darker material, circular wounds overlapping each other so densely that the ground looks like it has been struck for billions of years without rest. Every horizon would be scarred. Every direction would tell the same story. Impact after impact after impact. Callisto is often described as the most heavily cratered object in the solar system. And standing there, you would understand why. It would not feel like a moon that has lived peacefully beside Jupiter. It would feel like a moon that has spent 4 billion years absorbing the violence of space. And unlike Earth, Callisto did not erase that violence. Earth renews itself, rain falls, rivers cut valleys, oceans move sediments, volcanoes build new land, plate tectonics recycle crust, life covers scars with soil, forests, and cities. Callisto does almost none of that. Its surface has remained largely unchanged since the ancient history of the solar system. Some parts of the ground may predate complex life on Earth. Before forests, before animals, before humans, before anything with eyes looked up at the night sky, Callisto was already there, orbiting Jupiter, collecting craters. That gives the surface a strange emotional weight. A footprint on Callisto would be placed on a world that remembers deep time better than Earth does. But if humans ever went there, they would not only see ancient scars, they would see resources, because Callisto may look dead, but for survival, its surface is valuable. The ground is a mixture of ice, rock, and dark material. It is not the clean, bright ice world people often imagine when they think of Jupiter's moons. Europa shines with a pale, icy surface, cracked and bright. Callisto is darker, older, and dirtier. That darkness matters. Callisto's surface is coated with dark compounds, including carbon-rich material and altered organics. These are not signs of forests or life on the surface. They are chemical materials shaped by impacts, radiation, ancient delivery from space, and long exposure in the outer solar system. But for a colony, carbon is important. Carbon is one of the most useful elements for chemistry and manufacturing. It can become part of plastics, polymers, fuels, filters, agricultural chemistry, and many industrial processes. If future settlers can process Callisto's carbon-rich surface materials, they may not need to import every chemical feedstock from Earth. That is a major difference between simply visiting the moon and trying to live there. A visitor brings supplies. A colony must learn to use the world. And Callisto gives humans several things they would desperately need. The most important is water ice. Callisto contains enormous quantities of water ice across its surface and interior. Not just tiny traces, not just rare deposits hidden in one region. Ice is part of the moon's basic nature. Callisto is roughly a mixture of rock and ice, and that means water is one of its greatest survival advantages. For humans, water is more than comfort. Water is drinking. Water is hygiene. Water is agriculture. Water is radiation shielding. Water is oxygen. Water is fuel. A Callisto colony could mine ice from the surface or shallow subsurface, melt it, filter it, purify it, and use it for daily life. Compared with worlds where water must be hunted in rare deposits, Callisto's ice-rich crust makes survival more realistic. Processing surface ice into drinking water would still require machinery. Robots would scrape, drill, crush, heat, and refine icy regolith. The material would not be clean snow. It would be mixed with dust, rock, salts, and dark compounds. It would need filtration and chemical processing. But the basic ingredient is there. That is the key. The colony would not be starting from nothing. Ice could be mined and brought into sealed processing units. There, it would be melted into liquid water. Impurities would be removed. Some water would go to storage tanks. Some would go to farms. Some would become radiation shielding. Some would be split into hydrogen and oxygen through electrolysis. That oxygen could help fill habitats with breathable air. The hydrogen and oxygen could also be used for rocket propellant, energy storage, or industrial chemistry. This makes Callisto more than a scientific outpost. It could become a fuel station, a support base, a place where spacecraft exploring Jupiter's system could refuel using local resources instead of carrying everything from Earth. The surface ice would become the foundation of life and industry. Then there is the rock. Callisto's rocky material could provide construction resources. The regolith and mineral content could be processed into bricks, ceramics, glass-like materials, metals, shielding blocks, landing pads, roads, foundations, and structural components. A colony would not build itself from imported steel alone. That would be too expensive and too difficult. Instead, the first missions might bring advanced equipment, reactors, electronics, sealed habitat modules, and manufacturing systems. But over time, more and more of the colony would come from Callisto itself. Ice for water, ice for oxygen, regolith for shielding, rock for construction, carbon-rich compounds for chemistry. The moon becomes less like a barren place and more like a frozen warehouse. A difficult one, a dangerous one, but still a world with ingredients. Imagine the first construction site, not a city under open sky, not towers on the surface, a low industrial zone built into the side of an ancient crater. Robotic excavators move slowly in low gravity, digging trenches into the icy regolith. Modular habitats are lowered into the ground. The excavated material is piled over them, forming thick shielding against radiation and micrometeorites. Nearby, ice processing plants heat and refine frozen material. Pipes carry water into storage tanks. Electrolysis units produce oxygen. Power cables run from reactors or large energy systems into the buried base. Above the surface, antennas point toward Earth. Rovers crawl across crater rims. Landing pads are built from sintered regolith, hardened by heat into solid surfaces. The colony does not fight Callisto's surface. It uses it. That is the only way long-term survival works. The low gravity would help construction in some ways. Callisto's gravity is only about 12.6% of Earth's gravity. A person who weighs 80 kilograms on Earth would feel much lighter there. Heavy equipment would be easier to lift. Large structural pieces could be moved with less force. Excavated blocks of ice and rock would weigh far less than they would on Earth. Cranes could be smaller. Rovers could carry loads more easily. Humans in suits could move large tools with less effort. Building underground shelters might be easier in low gravity than on Earth, at least in terms of weight. But low gravity is not only an advantage, it is also a health problem. The human body evolved under Earth gravity. Our bones, muscles, heart, blood circulation, balance system, and posture all expect one full gravity. When humans spend long periods in low gravity or microgravity, the body begins to change. Bones lose density, muscles weaken, the cardiovascular system adapts, fluids shift, balance changes, the spine can stretch. The body becomes less prepared for Earth gravity. On Callisto, the gravity is higher than zero, but still very low. It is much weaker than Mars and weaker than the Moon. We do not yet know exactly how the human body would respond to living for years or generations at 12.6% Earth gravity. That uncertainty is serious. A Callisto colony might survive the environment, but struggle with biology. Astronauts would need strict exercise routines, resistance training, treadmills with harnesses, cycling machines, artificial loading suits, maybe rotating habitat sections that create artificial gravity for sleep or exercise. A long-term colony might need a rotating centrifuge module where people spend several hours each day under higher gravity. Children, pregnant people, and long-duration residents would raise even deeper questions. Could humans develop normally in Callisto gravity? Would bones grow properly? Would hearts adapt safely? Would returning to Earth become impossible for long-term settlers? We do not know. That unknown would shape every serious settlement plan. Callisto may be easier than Europa in radiation terms, but it does not solve the human body problem. Low gravity is quiet. It does not attack like radiation. It does not freeze machines like cold, but it slowly changes the body over time. A colony would need medicine, monitoring, exercise, and maybe artificial gravity technology to remain healthy. Then there is the cold. Callisto's average surface temperature is around minus 139 degrees Celsius. That is extremely cold, far colder than Antarctica, far colder than anything humans can survive without protection. But in the outer solar system, it is not the worst cold imaginable. Callisto is frozen, yes, but it is not as extreme as some distant worlds farther from the sun. With properly insulated habitats, heat sources, and buried structures, the temperature can be managed. Cold is dangerous, but it is also predictable. A habitat can be insulated. Waste heat from reactors and machinery can be used. Underground spaces can be thermally controlled. Pipes can be protected. Airlocks can be designed to reduce heat loss. Surface vehicles can be heated internally. The real challenge is maintenance. At minus 139 degrees, materials behave differently. Metals can become brittle. Seals can stiffen. Lubricants can fail. Batteries lose performance. Electronics need thermal regulation. Machines must be designed for deep cold from the beginning. Everything outside would need heaters or cold-tolerant engineering. A rover left inactive could freeze. A hinge could jam. A cable could crack. A drill could become stuck. Even simple tasks become complicated when the environment is that cold. But again, Callisto gives humans resources to fight back. Ice and regolith can insulate habitats. Underground construction reduces temperature swings. Nuclear power can provide reliable heat. Waste heat from industrial systems can warm living areas. Unlike Mercury, where the sun can overheat exposed structures, Callisto's problem is mostly keeping heat inside. That is difficult, but simpler in some ways. The cold does not change as violently as Mercury's day-night extremes. Callisto's environment is harsh, but steady. Steady danger is often easier to engineer around than rapidly changing danger. The surface itself would be visually haunting. Because Callisto is dark, the landscape would not look like a bright white ice field. It would be grey, brown, black, and dirty ice mixed with rock. Fresh impact craters might expose brighter ice beneath the surface, creating contrast between pale scars and dark ancient ground. Large impact basins would dominate the terrain, with concentric rings and fractured zones. The most famous basin is Valhalla, a huge multi-ring impact structure. From orbit, it looks like a gigantic frozen ripple, as if something struck Callisto and sent waves through its crust. Standing near such a basin, the scale would be hard to understand. The rings stretch across enormous distances. The terrain itself carries the memory of a collision so powerful that it reshaped a region of the moon. To a geologist, Callisto would be paradise. Not warm paradise, not living paradise, but scientific paradise. A surface that preserves the ancient impact history of the solar system. A record of bombardment. A window into how moons and planets were shaped. A place where each crater is a fossil of violence. For a colony, those craters could also be useful. Crater walls provide shelter from micrometeorite directions. Crater floors may contain useful deposits. Slopes could expose layers of subsurface material. Natural depressions could help shield habitats. A base might be built partially inside a crater, using the terrain as protection. But the surface also brings risks. Loose regolith, ice mixed with rock, unknown mechanical properties, possible weak layers, slopes and crater rims that could collapse, dust that clings to suits and machinery, low gravity that changes traction and movement. Every landing site would need careful mapping. A smooth-looking plane might hide loose material. A crater rim might provide a good view, but poor stability. A darker region might contain more useful carbon compounds, but different thermal behavior. Building on Callisto would begin with studying the ground, not just from orbit, up close, drilling, sampling, testing, mapping, learning how ice and rock behave under wheels, tracks, drills, anchors, foundations, and pressurized structures. The first human base would likely be prepared by robots long before people arrived. Robots would select the site. Robots would build landing pads. Robots would dig trenches. Robots would process ice. Robots would test water extraction. Robots would bury habitat modules. Robots would stockpile oxygen and fuel. Then humans would come. Because on a world as distant as Callisto, the first crew cannot arrive to an empty field and start from scratch. Rescue is too far. Supplies are too precious. The environment is too unforgiving. The base must already be partly alive before humans step inside it. When the crew arrives, they would find a small island of warmth inside an ancient frozen landscape, a place built from both Earth technology and Callisto material. The walls might be lined with water tanks for shielding. The outer shell covered in local regolith. The air made partly from Callisto ice. The drinking water mined from the ground outside. The first greenhouse lit by artificial lamps. The first bricks or panels made from processed local rock. Every part of the colony would represent a victory over distance. Because Callisto is far from Earth. Any supply mission takes time, planning, and huge energy. A self-sufficient colony must reduce dependence on Earth as quickly as possible. That is why Callisto's resources matter so much. A world with ice, rock, carbon compounds, and manageable radiation is not just a place to visit. It is a place that can support systems. Water systems, air systems, food systems, fuel systems, construction systems, maybe one day manufacturing systems. This is why Callisto may be one of the most self-sufficient colony locations in the outer solar system. Not the easiest, not the warmest, not the closest, but one of the most practical if the goal is to stay near Jupiter. Europa has more astrobiological excitement, but harsher radiation. Io has energy and volcanism, but is far too violent. Ganymede is huge and fascinating, but still more radiation exposed than Callisto. Callisto has the quiet advantage: ice, rock, distance, low radiation, stability, ancient terrain. It offers just enough for engineering to work. And that is all humans need at first. Not comfort, not Earth-like beauty, just enough. Enough water to drink, enough ice to make oxygen, enough material to shield habitats, enough carbon for chemistry, enough rock for construction, enough radiation safety to work, enough stability to build. But the cost would be psychological and biological. Low gravity would challenge the body. Cold would challenge machines. Darkness would challenge the mind. Distance would challenge the spirit. A Callisto settler would live in a world of muted colors, old craters, black sky, and constant artificial warmth. The outside would be beautiful in a silent way, but not welcoming. Every surface walk would require a suit. Every tool would need thermal protection. Every breath would depend on machines. And still, compared to many other worlds, Callisto offers something rare, a chance to use what is already there, to turn frozen ground into water, water into oxygen, ice into shielding, rock into shelter, carbon into chemistry, a dead landscape into a living outpost. That is what makes Callisto different. It does not look alive, but it may be one of the best places for life to survive with technology. Standing on its surface, you would see craters older than animals, ice darker than snow, Jupiter hanging in the distance, and the black sky of the outer solar system. You would feel the low gravity with every step. You would feel the cold pressing against the suit. You would know that beneath your boots is water, locked in frozen ground. And somewhere behind you, under layers of ice and regolith, a human habitat glows softly in the dark. Warm, pressurized, artificial, fragile, but real. A tiny pocket of earth built from the bones of an ancient moon. Callisto's surface is not friendly, but it is useful. And in deep space, useful may be the first form of hope. A Callisto colony would not begin as a city. It would begin as a machine trying not to die. Before humans ever arrived, robots would come first. They would land on the frozen surface, unfold antennas, test the ground, measure radiation, drill into the ice, map the terrain, and search for the safest place to build. And on Callisto, the safest place would probably not be an open flat plain. It would be a crater, a large ancient crater floor, or the edge of an old impact basin, where the walls of the landscape itself could offer protection. Not full protection, but enough to matter. Crater walls could block some micrometeorite directions. They could provide natural slopes for burying habitats. They could expose layers of ice and rock. They could create a place where the colony uses the moon's scars as shelter. That would be very Callisto. A world wounded by impacts for billions of years, and those same wounds becoming the first shelter for human life. The first structure would be simple compared to what might come later. A pressurized habitat module launched from Earth, carried across the solar system, landed carefully on the surface and checked by machines before the crew arrived. It would not look romantic. No glass domes, no shining city, no open parks beneath Jupiter. At first, it would be a sealed cylinder or cluster of modules, buried partly beneath local ice and regolith. Thick cables would connect it to power units. Pipes would connect it to water processing systems. Airlocks would lead to rover garages and maintenance tunnels. External cameras would replace windows. Every wall would be functional. Every kilogram would have a purpose. This first habitat would be Earth's small artificial island on an ancient moon. Inside, there would be pressure, warmth, air, water, light. Outside, there would be vacuum, cold, radiation, darkness, and 4 billion years of silence. The first crew would arrive only after the base had already proven that it could keep itself alive. The machines would need to show that they could generate power, extract water, store oxygen, maintain temperature, and communicate with Earth. Because on Callisto, failure is not something you solve quickly. Earth is too far away. No rescue ship can arrive in days. No emergency supply can be rushed overnight. A serious failure on Callisto would have to be solved by the people already there, using the tools already there, with the knowledge already inside the colony. That means the first colony would be built around redundancy. 2 power systems, not 1. Multiple water processing lines, backup oxygen generators, spare pumps, spare seals, spare computers, spare airlock parts, repair robots, emergency shelters, a medical bay prepared for problems no doctor on Earth could physically reach in time. The first rule of Callisto would be simple. If you need Earth to survive the emergency, you have already lost. That is why the transition from Earth-supplied outpost to self-sufficient colony would be the most important chapter in Callisto's human story. At first, everything critical would come from Earth. Habitat modules, reactors, electronics, medical equipment, food reserves, tools, robotic excavators, life support systems. But this cannot continue forever. A colony that depends completely on Earth is not truly a colony. It is a distant station waiting for supplies. To survive long-term, Callisto would need to begin using Callisto, and the first permanent industry would almost certainly be ice mining. Water ice is the foundation of everything. Robots would dig into the surface, collect ice-rich regolith, crush it, heat it, and separate water from dust, rock, salts, and dark organic material. The water would be purified and stored in insulated tanks beneath the surface. Some would become drinking water. Some would be used for washing and hygiene. Some would feed the hydroponic farms. Some would be placed around living quarters as radiation shielding. And some would be split through electrolysis into hydrogen and oxygen. The oxygen would become breathable air. The hydrogen could be stored for fuel, chemical processing, or combined again with oxygen when needed. This would be the moment Callisto starts giving life to the colony. Not life in the biological sense, but the raw material of life. Water from the frozen ground becoming breath inside a human habitat. That transformation would feel almost sacred. A moon that has been silent for billions of years suddenly helping humans breathe. But water alone is not enough. A colony also needs power. And on Callisto, solar power is weak. Jupiter is about 5 times farther from the Sun than Earth. And because sunlight spreads out with distance, solar panels near Jupiter receive only about 4% of the sunlight they would receive near Earth. That does not make solar power completely useless, but it makes it difficult as the main energy source for a serious colony. Solar farms would need to be enormous. They would need to work under weak sunlight, cold temperatures, dust, darkness, and long operational stress. For a small robotic probe, solar can work in some cases. For a permanent human settlement, depending only on solar power would be risky. Callisto would need nuclear power. Nuclear fission would likely be the first reliable energy source. Compact reactors could provide steady heat and electricity day and night, independent of the weak sun. They could power habitats, mining equipment, water processing, oxygen generation, lights, computers, communication systems, medical equipment, and farms. On Earth, nuclear power is often debated. On Callisto, it may be the difference between life and death. A reactor would not just be an energy plant. It would be the colony's heart. Its heat could warm underground habitats. Its electricity could keep oxygen flowing. Its stability could allow people to sleep without wondering whether the sun is strong enough today. The reactor site would be placed away from the main living quarters, shielded, monitored, and built with layers of emergency protection. Heat pipes or electric lines would carry power to the colony. Backup reactors would exist because a single power source would never be acceptable. A Callisto colony would not need dramatic sunlight. It would need quiet, constant energy, and nuclear fission offers exactly that. With power and water, the next problem is food. No human settlement survives long-term on stored meals alone. At first, food would come from Earth: dried meals, packaged nutrition, emergency supplies, seeds, starter cultures, algae strains, fungi, and nutrient systems. But eventually, food production must move inside the colony. Callisto has no sunlight useful for conventional agriculture, no open fields, no soil ecosystem, no rain, no atmosphere, no natural growing season. The farms would be underground, sealed, and completely artificial. Hydroponic chambers would grow plants in nutrient-rich water. Aeroponic systems might grow roots in mist. LED lighting would replace the sun. Carbon dioxide from human breathing could be recycled into the plant system. Water would be captured, filtered, and reused again and again. But early Callisto agriculture might not begin with wheat fields or fruit trees. It would begin with efficient life: algae, fungi, mushrooms, microgreens, yeasts, maybe insects, if the colony accepts them as a protein source. Algae can grow quickly and produce oxygen, oils, proteins, and nutrients. Fungi can grow in controlled environments and turn waste streams into edible biomass. Mushrooms require less light than traditional crops. These would not be glamorous foods, but they would be practical. The first Callisto diet might be strange: algae-based protein, mushroom cultures, hydroponic greens, lab-grown carbohydrates, recycled water, carefully balanced vitamins. Food designed not for luxury, but for survival. Over time, as the colony grows, the farms would become more complex. Leafy vegetables, beans, potatoes, grains, fruiting plants, maybe even small orchards inside large pressurized chambers. The agricultural areas would become the most emotionally important places in the colony because they would be green. On the moon of grey ice and black sky, green would become precious. A plant growing under artificial light would not only be food, it would be proof that Earth had not been completely left behind. A child walking through a Callisto greenhouse might see leaves before ever seeing an ocean. They might smell damp growing chambers before ever smelling rain. They might learn that food comes not from fields under a blue sky, but from sealed rooms beneath ancient ice. That is what building a colony means. You do not just build shelter, you build a new normal. And slowly, the colony would change. The first generation would still feel like visitors from Earth. They would remember Earth's gravity, Earth's sky, Earth's weather, Earth's open air. They would compare everything to home. But the children born on Callisto would be different. They would grow up in low gravity, in tunnels, in artificial light, in a world where Jupiter is the great presence in the sky, seen through cameras and shielded observation rooms. For them, Earth would not be memory, it would be story. a blue planet shown in recordings, a place where people walk outside without suits, a place where water falls from the sky, a place with animals, forests, oceans, storms, cities, and air, a place so rich and open it might feel almost mythical. They might look at Earth the way ancient people looked at the heavens, not as a normal location, but as a beautiful origin, a sacred point, a distant parent world. From Callisto, Earth would be only a tiny blue dot, lost near the sun's glare depending on the geometry. It would not dominate the sky. It would not look like home to someone who had never been there. Home would be the colony, the buried rooms, the farms, the reactor hum, the ice mines, the crater outside, the giant Jupiter in the black sky. This is where survival becomes culture. A Callisto colony would develop its own habits quickly because isolation would force it. Communication with Earth would be delayed by roughly 35 to 52 minutes one way, depending on the positions of Earth and Jupiter. That means a simple question and answer could take more than an hour and a half. Real-time conversation would be impossible. No instant help, no live medical consultation in an emergency, no immediate command from mission control. At first, Earth would still guide the colony. Engineers, doctors, scientists, and mission planners would send instructions, analysis, and support. But the delay would force Callisto settlers to make their own decisions. A fire in a habitat, a pressure leak, a reactor warning, a medical crisis, a rover accident, a mining collapse. They could inform Earth, but they could not wait for Earth. They would act first. Earth would become advisor, not commander. And within one generation, that difference would become political. The people on Callisto would know the risks better than anyone on Earth. They would know the machines, the terrain, the failures, the social tensions, the daily reality of living there. They would begin to ask, why should Earth decide everything? Why should a planet 500 million kilometers away control a society that must solve its own emergencies? The delay in communication would create independence long before any formal declaration. Callisto would become self-governing because physics demands it. Distance creates autonomy, and autonomy creates identity. The minimum viable colony would need enough people to survive socially, technically, medically, and genetically. Some estimates for isolated, self-sustaining populations suggest numbers in the range of at least 150 to 200 people as a starting point, though a truly healthy long-term civilization would likely need more, or continued genetic and technological exchange with Earth. But a small outpost of 10 or 20 people is not a society. It is a crew. A colony needs doctors, engineers, farmers, teachers, technicians, builders, biologists, programmers, mechanics, geologists, reactor specialists, psychologists, and children. It needs people who repair pumps, people who grow food, people who deliver babies, people who teach history, people who maintain law, people who know how to calm panic, people who can make music in a place where silence is always waiting outside. That last part matters. A colony is not only a machine, it is human life under pressure. The social structure of Callisto would have to be careful. Too much hierarchy could become oppressive in a closed world. Too little structure could become dangerous during emergencies. The colony would need trust, clear roles, shared responsibilities, and a culture of maintenance. Maintenance would almost become a religion. Check the seals, check the filters, check the reactor, check the water, check the oxygen, check the crops, check the radiation, check the pressure, check the mental health of the person beside you. On Earth, a broken system is inconvenient. On Callisto, a broken system can become death. So the society would value reliability more than speed, calm more than ego, cooperation more than individual drama. A reckless person on Callisto is not exciting. They are dangerous. Over time, traditions would form around survival. Daily system checks, shared meals in the greenhouse, Jupiter viewing nights through shielded cameras, ceremonies when new water tanks are filled from local ice, celebrations when the first child is born, memorials for Earth, maybe even holidays based on the arrival of supply ships, or the first day the colony produced more oxygen than it consumed, or the day the first habitat became fully built from local materials. These are the things that turn an outpost into a home, and the architecture would grow with the society. The first module would become a cluster. The cluster would become buried corridors. The corridors would connect to mining shafts, farms, workshops, storage chambers, medical rooms, schools, laboratories, recreation areas, and artificial gravity exercise modules. Crater walls might hold communication towers and radiation monitors. Ice mines would expand outward. Manufacturing plants would begin producing simple parts. Landing pads would become a small spaceport. Fuel depots would store hydrogen and oxygen. Robotic missions to Europa and Ganymede might launch from Callisto orbit. The colony would become a working base for the entire Jovian system, a quiet human foothold in the kingdom of Jupiter. Within 50 years, if the colony succeeds, it may no longer need Earth in the same way. Not completely independent in every advanced technology, perhaps. Microchips, medicine, specialized equipment, and complex instruments might still come from Earth for a long time. But for daily survival, water, oxygen, food, shielding, basic construction, fuel, heat, power, Callisto could begin to stand on its own. That would be the true turning point. When Earth becomes heritage instead of lifeline. When supply ships become helpful, not essential. When the colony can survive a missed launch window. When children born there do not fear that a delay from Earth means the end. That is when Callisto becomes a world humans inhabit, not just a place humans visit. But it would never be easy. Every part of life would be enclosed, every breath manufactured, every meal planned, every emergency local, every person necessary. A Callisto colony would be one of the most isolated societies in human history. More isolated than Antarctic stations, more isolated than submarines, more isolated than space stations. Because Earth would not be below them in orbit. Earth would be far away, across the deep solar system, behind a delay that makes comfort arrive late. And yet, there would be beauty. A beauty that belongs only to places on the edge. Imagine the colony at night. Though night on Callisto is not like night on Earth. Inside the habitat, the lights dim to an artificial evening. The greenhouse glows softly. Water moves through pipes. Somewhere, a reactor hums. Children sleep in rooms shielded by ice. Outside, the black sky holds Jupiter, enormous and silent. No wind touches the surface. No rain falls. No animal calls. Only the frozen crater plains stretch into darkness. And beneath them, human life continues, small, warm, fragile, but stubborn. That is what a Callisto colony would really be. Not a conquest of Jupiter's moon, not a shining fantasy city, but a careful agreement between humans and a frozen ancient world. We bring heat, Callisto gives ice. We bring machines, Callisto gives shielding. We bring biology, Callisto gives space. We bring memory of Earth. Callisto becomes home for those who have never known Earth at all. And perhaps that is the most powerful part. The first settlers would look back toward Earth with longing. Their children would look back with curiosity. Their grandchildren might look back with reverence, but not homesickness. Because home is not only where life begins, home is where life learns to continue. And on Callisto, under ancient ice, inside buried habitats, beneath Jupiter's silent gaze, humanity might learn to continue farther from the sun than ever before. After everything we have learned, the honest question is no longer whether Callisto is dangerous. Of course it is dangerous. It is a frozen moon orbiting Jupiter, far beyond Mars, far beyond the asteroid belt, in a region of the solar system where sunlight is weak, rescue is impossible, and every human breath would depend on machines. No one would survive on Callisto naturally. There is no air, no open water, no warm surface, no plants, no weather, no blue sky, no easy return. But survival in space has never meant finding places that already feel like Earth. It means finding places where technology has enough to work with. And Callisto, surprisingly, gives us more than most. Radiation, the greatest danger near Jupiter, is more manageable here than on any other Galilean moon. Water and oxygen are possible because ice is abundant and accessible. Construction materials exist in the surface itself. Energy is difficult, but nuclear power makes it possible. Food is challenging, but solvable through closed farms, algae, fungi, hydroponics, and recycling. The temperature is brutally cold, but stable enough for insulated habitats to survive. So when we ask, could humans actually do it? The answer is yes. Not easily, not soon, not cheaply. But yes, in theory, Callisto is one of the most realistic places for a human foothold in the outer solar system. That is what makes this moon so important. It is not the most famous. It is not the most beautiful. It is not the first place people imagine when they dream of space colonization. Mars gets the attention. Europa gets the mystery. Titan gets the atmosphere. But Callisto has something quieter and maybe more valuable. Balance. It is close enough to Jupiter to become a base for exploring the giant planet system, but far enough away to avoid the worst radiation. It is rich enough in ice to support survival, but stable enough that humans could build on it. It is harsh, but not impossibly hostile. That combination is rare, and NASA has known this for a long time. In the early 2000s, NASA studied ideas for human exploration beyond Mars, and Callisto appeared as a serious destination. It was not chosen randomly. It was chosen because among Jupiter's moons, Callisto offered the best compromise between science, resources, and survivability. There was also the Jupiter Icy Moons Orbiter, often called JIMO, a bold mission concept that would have used nuclear electric propulsion to study Jupiter's icy moons. It was eventually cancelled, not because Callisto suddenly became impossible, but because the mission was enormously expensive, technologically ambitious, and difficult to fit into NASA's budget and priorities. That difference matters. A mission being cancelled does not mean the destination is worthless. It means the timing, money, and technology were not ready. Callisto remains scientifically important, and today the story continues with new missions. ESA's JUICE mission, the Jupiter Icy Moons Explorer, is already on its long journey to the Jovian system. It is designed to study Jupiter and its icy moons, including Ganymede, Europa, and Callisto. JUICE has not yet reached Callisto, but when it does, it will help us understand these moons more deeply than ever before. It will measure surfaces, study magnetic environments, examine ice, map geology, investigate possible subsurface oceans. And for Callisto, every new piece of data matters, because if humans ever go there, they will not go blindly. They will need maps, radiation measurements, surface composition, ice distribution, crater stability, landing zone analysis, thermal models, communication planning, orbital data. Everything that future missions learn now becomes the foundation for survival later. A human colony begins long before humans land. It begins with orbiters, flybys, robotic scouts, surface probes, drillers, mapping satellites, autonomous construction machines. The first human footprint on Callisto would only happen after decades of preparation, and the technology still has to mature. The first major requirement is propulsion. Callisto is far away. Chemical rockets can reach Jupiter, but for human missions, travel time is a major problem. The longer the journey, the more food, water, shielding, life support, medical capability, and psychological endurance are required. This is why nuclear thermal propulsion becomes so important. A nuclear thermal rocket could heat propellant using a reactor and provide far greater efficiency than traditional chemical engines. It could reduce travel times and make deep space human missions more practical. For Mars, nuclear propulsion is already discussed as a future advantage. For Callisto, it may be essential. A journey to Jupiter with humans cannot feel like a fragile one-way gamble. The spacecraft must be fast enough, reliable enough, and well-shielded enough to protect the crew for the entire journey. Then comes life support. A Callisto colony cannot depend on constant resupply from Earth. Advanced closed-loop life support systems must be perfected first. Water must be recycled. Air must be regenerated. Waste must be processed. Food must be grown. Systems must repair themselves or be repairable with local materials. The good news is that much of this technology is already being developed for the Moon and Mars. Everything we learn from Mars missions applies to Callisto. Radiation shielding, underground habitats, in situ resource utilization, water extraction, oxygen production, hydroponic farming, nuclear surface power, closed-loop recycling, dust management, crew psychology, remote medicine, autonomous robotics. Mars is not the end goal. Mars is the training ground. The Moon teaches us how to live off Earth. Mars teaches us how to live on another planet. Callisto teaches us how to live in the outer solar system. That is the stepping stone strategy. Moon first, then Mars, then the asteroids, then Callisto. Each step teaches humanity how to survive farther from home. By the time humans are ready for Callisto, they will need to have mastered things that are still difficult today. Long-duration habitats, reliable nuclear power, advanced propulsion, artificial gravity or strong countermeasures for low gravity, robotic construction before crew arrival, medical independence, large-scale recycling, local manufacturing, closed agriculture, emergency autonomy. A Callisto mission would not be Apollo. Apollo was brave, brilliant, and short. Callisto would be slow, heavy, prepared, and permanent. The earliest realistic human mission to Callisto would probably not happen before the second half of this century. Perhaps the 2060s, 2070s, or 2080s, depending on how fast space technology develops and how seriously humanity commits to deep space exploration. That sounds far away, but it is not impossibly far. The generation that will make this decision is already alive. Some child alive today may grow up to design the first Callisto habitat. Some teenager alive today may become the engineer who solves nuclear propulsion. Some student today may work on the life support system that lets humans breathe beneath Callisto's ice. The future does not arrive all at once. It is built quietly by people who begin before the world fully believes it is possible. And that is what Callisto requires. Belief, but not fantasy. Ambition, but not recklessness. A colony there would be one of the hardest things humanity has ever attempted. The distance alone changes everything. When something goes wrong, Earth cannot help quickly. Communication delay means the colony must think for itself. Depending on the positions of Earth and Jupiter, messages can take around 35 to 52 minutes one way. That means a question sent to Earth may not receive an answer for well over an hour. In an emergency, that is too late. A pressure leak must be fixed locally. A reactor problem must be handled locally. A medical crisis must be treated locally. A failed oxygen system must be repaired locally. Callisto settlers would not be remote employees of Earth. They would become an independent society almost immediately because physics forces independence. This is one of the most important truths about deep space. Distance creates freedom, but it also creates responsibility. A Callisto colony would have to govern itself, repair itself, feed itself, protect itself, and eventually reproduce itself culturally. Within one generation, the people born there would not feel like temporary visitors. They would feel like Callistans. And that raises the philosophical question: why would anyone choose Callisto over Mars? Mars is closer. Mars has more sunlight. Mars has a day similar to Earth's. Mars has an atmosphere, even if thin. Mars has valleys, volcanoes, polar caps, and a romantic place in human imagination. Mars feels like the obvious next world. So why Callisto? Because Callisto is not competing with Mars. Callisto is the gateway to something else. Mars is humanity's first step toward becoming multiplanetary. Callisto could be humanity's first step toward the outer solar system. From Callisto, Jupiter's entire system becomes accessible. Europa, with its hidden ocean. Ganymede, the largest moon in the solar system. Io, the volcanic world. Jupiter itself, with its storms, magnetosphere, auroras, and deep atmospheric mysteries. A Callisto base could control robotic missions to all of them. It could refuel spacecraft. It could serve as a repair station. It could become the safest human harbor near Jupiter. That is why the sacrifices might be justified. Callisto is not only a colony site, it is a platform, a base camp, a doorway. From Earth, Jupiter is far away. From Callisto, Jupiter is the neighborhood. Robots could be sent to Europa's surface without risking human lives inside the harsh radiation zone. Probes could study Ganymede. Flyby missions could monitor Io's volcanoes. Orbiters could dip into Jupiter's magnetic environment and return data to a nearby human-controlled hub. The scientific return would be enormous. We could study the origin of icy moons, search for subsurface oceans, understand Jupiter's radiation environment, learn how giant planets shape their satellite systems, study impact history preserved on Callisto's ancient surface, test whether humans can live using local resources far from the sun, and perhaps most importantly, we could learn how to build civilization where Earth is no longer nearby. That knowledge may matter beyond Jupiter. If humans can survive on Callisto, they can begin thinking seriously about Saturn's moons, about Titan, about Enceladus, about the Kuiper Belt, about generation ships, about living in cold, distant places where sunlight is weak and every system must be self-sustaining. Callisto may be the training ground for a much larger human future. But it would not feel grand every day. Most days would be maintenance, checking pipes, repairing seals, monitoring reactors, testing water purity, watching oxygen levels, maintaining farms, running exercise schedules, inspecting mining robots, updating radiation models, teaching children, managing stress, holding the community together. The heroic image of space colonization often focuses on the first landing, the first footprint, the first flag, the first words. But real colonization is not the first moment. It is the 1,000th day, the 10,000th repair, the meal grown locally, the child safely born, the emergency survived, the year when no supply ship arrives and the colony continues anyway. That is when a colony becomes real. Could Callisto reach that point? Yes, but only if humans respect what it is. Callisto will never be Earth. It will never offer open fields, blue oceans, warm air, or easy sunlight. It will offer ice, darkness, low gravity, cold, craters, and distance. The colony must turn those into advantages. Ice becomes water. Water becomes oxygen. Regolith becomes shielding. Crater walls become shelter. Distance from Jupiter becomes radiation safety. Isolation becomes independence. The same things that make Callisto seem lonely are the things that may make it livable. And maybe that is why this moon matters so much. It teaches us that survival is not always found in the obvious places. Sometimes the most important world is not the brightest, not the closest, not the most dramatic, but the one that quietly gives you enough safety, enough material, enough stability, enough time. Callisto gives enough, and in the outer solar system, enough is everything. Tonight, as you drift to sleep, somewhere beyond Mars, beyond the asteroid belt, beyond the comfortable warmth of the inner solar system, Callisto continues its slow orbit around Jupiter. Ancient, silent, covered in scars from 4 billion years of cosmic violence. A moon that has watched impacts come and go. A moon that has remained almost unchanged while Earth became alive, green, restless, and full of voices. And beneath those craters, water waits, frozen, patient, ancient, ice that may have existed since before complex life appeared on Earth. Enough water to sustain explorers, enough water to make oxygen, enough water to grow food beneath artificial lights, enough water perhaps to support a small human civilization for thousands of years. Callisto is not the most beautiful of Jupiter's moons. It is not the most active. It is not the most famous. It does not shout for our attention. But it may be the most important. The quiet moon, the safe moon, the moon that waits outside Jupiter's worst radiation, the world that could become humanity's first true harbor in the outer solar system. And maybe one day, beneath its ancient ice, human lights will glow, a reactor will hum, water will flow through pipes, plants will grow under lamps, children will learn that Earth is a blue star near the sun, and Jupiter will hang above them, enormous and silent, watching over the first people who learned to call Callisto home. The moon has waited for billions of years. Perhaps it is still waiting for us to finally arrive.